This graph would be titled Position versus Time because position is on the vertical axis or the y-axis, and because time is on the horizontal axis or the x-axis. So the name of the graph always corresponds to the vertical versus the horizontal, or the y versus the x. When we make our graphs of motion, we almost always put time along the horizontal axis, no matter how the information was gathered. So position will be on the vertical and time will be on the horizontal in the graphs we look at today. So what do those axes tell us about the slope? Well, we can really take a look at just our basic definition of slope, remembering that it's the rise over the run. And if we match that up with how our axes have been labeled, just looking at what's on the vertical axis, what's on the horizontal axis, we can see that for this graph, our slope will tell us something about meters over seconds. The slope will have units of meters per second. So it's a velocity. Without really memorizing anything, just looking at the graph, we can tell what the slope is going to tell us. So how does that relate to the object's motion? Well, we're going to need to break this graph into three parts because there's three very distinct slopes in our graph. Again, keep in mind that slope is telling us about the velocity, how fast and in what direction. So let's look at this yellow section first. This is a positive slope. We can see that the object goes from position 50 to position 100, so it's moving away from the origin, and this lasts about 20 seconds. If we look at the next section, here the graph is flat, the slope is 0. This object is not moving. It has a velocity of 0. It just stands still at that 100-meter mark for those full 10 seconds, 20 to 30. And then in our last section, looking from t equals 30 to 40 seconds, here our graph now slopes downward. A negative slope means the object moves toward the origin, back towards the direction it originally came from. Our slope value, it would be negative, but it would also be a much greater number than in the yellow section. So we know that it's traveling faster during this red section. All right, so what happens if our graph happens to be curved? We've only looked at really sort of straight lines. Let's take a look at the C graph in this one. This is a graph we'll look at in a later video. But let's look at the C graph and notice that in the beginning, the slope is very low, okay, very shallow. A little bit later, the slope is getting greater. The line is getting steeper. At the end, it's very steep. So what this means is that the slope is increasing, so the velocity is increasing. So we would say that this object is accelerating. It's a very smooth acceleration because the graph is curved. And again, this is a topic that we'll get to a little bit later.